What's going on, Trig family? Hope you're all doing well. The next section here that we're going to cover is basically the same as the last, given that we're now going to be taking approximations of these trig function values rather than the exact values. So the difference being, as I mentioned in the last video, using the fraction, ratios, square roots, things of that nature will stay in exact, where we can only use those with a special right triangle like our reference angles of 30, 45, 60, or any quadrantal or multiple of 90. Now we'll be able to do that with any angle, not just those ones. And unfortunately, they're not going to be nice. So we're going to have to approximate them, which means we're going to need a calculator. So for this one, make sure you have your scientific calculator. Don't need anything special like a graphing, but definitely going to need a calculator that has the trig function values on it. So without further ado, let's get to it. So as I mentioned in this section, we are going to need a calculator in order to approximate answers. So whenever they ask you to approximate, calculator use. If not, then they're going to want the exact answer, which means you're going to have those special reference angles memorized. Okay? So as we've talked about, not much new. These are your notes. Best section yet. All right. So let's do some examples and make sure that we can do all the stuff that we've been working on, but now with angles that aren't as nice as the 30, 45, and 60 reference angles in any quadrant. So example number one here, you can see that they gave us some different forms. The minutes, seconds symbols are now there. All right, in this case, only minutes in degrees. And they're asking us to find the approximate to, make sure you're paying attention to this, 6 decimal places for the cosine of 41 degrees in 24 minutes. So if you know how to use your calculator, you can make sure it's in the degrees, minutes, seconds, or if not, you can change it to decimal degrees and then evaluate it. So all you're going to have to practice, once again, like we did early on in the beginning of this course, is we're going to have to take those 24 minutes and multiply it by that fancy 1. And that fancy 1 for us is going to try to get rid of the minutes and change it to degrees. So we need to know that direct relationship, which hopefully we know that 60 minutes is equivalent to 1 degree. So I know it doesn't look like a 1, but you know that we can change this to 60 minutes or this to 1 degree, and it would have the same thing on top as the bottom. So that then allows us very nicely to cancel the minutes and have just our unit measure of degrees. But when multiplying across, we can just get 24 over 60 degrees, or we know that we can punch that in our calculator or even simplify it by 6. 6 goes into the top 4 times and that 10 times, and I'm going to go ahead and leave it as 4/10, even though I know I can simplify that more, because if you say 4/10 as a fraction, you can also say that 4/10 as a decimal. So I know if I punch that in the calculator, or I can get it to be a denominator of 10, 100, or 1,000, then I have it in its decimal form as well. So this is equivalent to saying the cosine of 41.4 degrees. So whether you punch that in your calculator or that in your calculator, that's what we're going to have to evaluate. And so I'm going to pull up my calculator real quick and do the cosine of 41.4 degrees. Hit enter. Just make sure that your calculator is in degrees and not radians or anything else that we don't technically know anything about yet. But remember, they wanted 6 decimal places, so I'd have to take that 0.750111, and that would be my final answer to either one of those. All right, if you want to go ahead and pause it and try part B on your own, more than welcome to. Otherwise, I'll go ahead and explain it now. All right, if you tried it on your own, great. If not, here we go. We're going to try to take tangent of -80. Don't forget the negative there. Keep your signs. And then 0.6 minutes, meaning that I'm going to change that to a decimal so that I don't have to try to figure out a new way to do my calculator. This isn't bad. 6 minutes. We're going to multiply that by 1 to get rid of the minutes and change it to degrees. I know that there are 60 of these in one of those. And so the minutes will cancel out, and also the 6 and the 60 to give me, when I multiply straight across, 1/10 of a degree, which is equivalent to 0.1. So I know that that's what goes there, and this is the same as that. So I will go to my calculator, making sure again that it's in degrees. I will hit tangent of -80.1 and then hit equals. Now don't hit the minus sign instead of the negative. And you can see we got -5.72974, and then we'd have to round that to a 2 will be our final answer there. All right. Now this next one, this last one here is a little tricky. If you want to go ahead and try to pause it and do this one on your own, please do, but it's a fraction, and we don't like fractions. We don't want to evaluate this the way that it currently is. So if you remember, whenever we have 1 over a trig function, in this case, secant of some angle theta, they're giving us a 14.8 degree measurement. That should be equivalent to its reciprocal function for that exact same angle, right? So again, if you aren't sure about that, remember cosine is always equal to the x over the r, and secant is equal to r over x. So I actually have 1 over r over x. And if I wanted to get rid of the fractions within fractions here, we could multiply by its reciprocal, which would be x over r. And as long as I do it to the top and the bottom, again, this is just a fancy 1 here. And so when I multiply this by 1, you can see what happens is that the x's on the denominator and the r's in the denominator would all cancel out to be 1s. So all we're left with is x over r, which is our cosine. So we know that these are equivalent. So what we're going to do is we're just going to simply rewrite this as the cosine of 14.8 degrees. And now we can just evaluate that. So be careful when punching that in your calculator. You should get 0.966823. Remember, if it says to round to 6 decimal places, you're going to have to look at the 7th to see whether you should round up or down. Okay? And hopefully you understand rounding. We actually only have 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are the only 10 digits that exist. And if you notice, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. If we were to split those in half, it would be 5. So if I was to draw a line for the first 5, 1, 2, 3, 4, 5, that would be here. And then the second 5, 1, 2, 3, 4, 5 would be there. And since this half is closer to the next biggest number, we round up. And since this half is closer to the number that we already have, we keep it the same and round down. All right, a lot of people never really understood why it was 5, but hopefully this makes total sense because there are 5 numbers on this side and 5 numbers on this side. So when we literally cut it in half, 5 and above will round up, 0 to 4, which is the lesser 5, will keep and round down.